Hello everyone, welcome back to my channel Easy Learning League, and we are doing the parabola related topics. And in the previous video we have discussed what is the shifting of the vertex in parabola. So now we will understand the definition of the parabola and its general definition and its standard equation, and also know that shifting of the origin, and do some questions also. So let's get started. So what is the parabola? So we can say that it is a part of the coordinate geometry. Okay, it is a part of the coordinate geometry, and definition is that a conic section or conic is the locus of the point which moves in a plane such that its distance from a fixed point is in constant ratio to its distance from a fixed line. So what is the locus of the point, or what is the locus? So locus, we can say that locus is a path traced by a point. Okay, locus is a path. So parabola is what? Parabola is also a path, and ellipse is what? Ellipse is also a path. So let's see, let me explain you this definition. Suppose this is a moving point P. This is a moving point P, and its coordinate is x comma y, and this is the straight line. This is the straight line ax plus by plus c equal to 0, and the moving point P2 straight line. This is the perpendicular. The distance of the P2, this is the point P, to M. Distance of P from the fixed line is called the perpendicular, and this is called the focus. This is called focus S, and its coordinate is a comma b, and its distance also from P is like that. So this is the diagram. So we can say that a P is a moving point in such a way that its ratio of distance from a fixed line is a fixed distance. Means let's call it SP and PM. This line is SP and this line is PM. So we can write SP upon PM will be constant according to the definition. Will be constant according to the definition, because definition says that its distance from a fixed point is in constant ratio from its distance a fixed line. So the distance from a focus and distance from a line from the moving point P, so the ratio of these SP upon NP will be constant. Okay, so this is condition in which this point is moving. So now that's the distance of the point P from the fixed point and distance of the point P from the line SP by mm. That is called the ratio. Okay, that is called the ratio. This is the ratio. But question is that what is this constant? What is this constant? So we can say that this constant represent an eccentricity. Okay, this is the eccentricity, and we can denote eccentricity by E. So I will giving you all those definition. I'm just giving you a quick trailer. What are we going to learn? So this constant is known as, we can write this constant is known as eccentricity. Okay, and we can say eccentricity for different values will give the different curves. eccentricity for different values gives different curves. Let me explain you. If the eccentricity will be equal to 0, then it will gives parabola. If the eccentricity is greater than 1, it will gives hyperbola. And if the eccentricity is greater than 0 and less than 1, so it will gives ellipse. Okay, so it's all depend on the eccentricity. So this is the general definition of the conic. Let's see the diagram of the parabola. This is the y-axis and this is the x-axis. Okay, and this point is moving point which make the parabola by moving p, and its coordinate is x comma y. Okay, and this is perpendicular to the m distance. And it is the focus. We called focus. The distance of focus is ps. So this moving point is made in parabola like that, and this is called vertex. This point is called vertex, and this is the axis of the parabolas. X-axis and y-axis, this is the axis of parabolas. And this length is called directrix. This is the conic, means parabola. This is the point P, x comma y, or you can say also h comma k, and this is the focus. So now you understand the important point is the fixed point S is called focus, and fixed straight line is called the directrix, and constant ratio PS upon PM, constant ratio, is called the eccentricity of the conic. Okay, so this is the whole definition. A line through the focus and perpendicular the directrix is called the axis. A line through the focus and perpendicular to the directrix, we are talking about this line, so this is called the axis. And the point of the intersection of the conic with its axis is called is vertex. This is the point of the intersection of the conic, so it is called vertex. And what about the chord? What is the chord? So we can say that a chord perpendicular to the axis is called double ordinate. Perpendicular to the axis, this is the chord. Okay, this is the chord. So it is the perpendicular to the axis, so it is called double ordinate. And then what is the focus? In particular, the double ordinate through the focus, the double ordinate, this is the double ordinate and is going through the focus, so we can say that it is a lattice rectum. Lattice rectum. So this is the whole definition of the parabola. And now let's talk some more important about the eccentricity. The eccentricity when is equal 1, it gives parabola. When eccentricity is greater than 1, it gives hyperbola. And when the eccentricity is greater than 0 and less than 1, it is called ellipse. So let's move ahead. If the eccentricity is given E equal to 1, so we already know it gives the parabola, and SP upon PM equal to E, so we can say that SP upon PM equal to 1. Okay, and you can also say that SP equal to PM. So means let's understand this definition by diagram. This is the y-axis and this is the point P, moving point, and this is the focus S, and it's the distance from the focus, and this is the distance from the directrix, and this point is moving, and it's make a parabola like that. It's make the parabola like that. The distance of SP equal to PM as per the definition. The distance from point P to focus and point P to directrix will be equal to the distance of P from the focus to the directrix will be equal to, because this moving point makes the same distance from the directrix and from the focus. The definition says that, as the definition says that PM equal to PS when E equal to 1. So we are moving this point P in such a way that its distance from the axis and its distance from the directrix gives the ratio is 1 basically, and SP and MPM are equal. Okay, so in what manner this point P can move? So we can answer, this point P will be moving in a parabolic manner. This is moving in a parabolic manner. I hope you understand what I am saying. So now we will understand how to get the general equation of the conic. How to get general equation of the conic. So if you try to find the general equation of the conic with focus, and focus is given S equal to, the coordinate is alpha comma beta, and directrix is ax plus by plus c equal to 0, and eccentricity is 1 because it's talking about the parabola. And so if these three things are given, so we can derive the equation of the conic or parabola. And we all know condition is that PS upon PM will equal to eccentricity. So now we will squaring on both sides. Squaring on both sides, then PS whole square equal to E square PM whole square. Right, doing squaring on both sides. So few things you must know, that the distance of, let me make the graph of this. This is the point P, moving point H comma K. Okay, and this is the perpendicular from the directrix M, and this is the focus, and its coordinates, it's alpha comma beta. So you can clearly see in this, the distance of the PS will be, this is the distance from from this point, and this is the directrix, which equation is ax plus by plus c equal to 0. So now first you will find the distance of the PS, and you already know the formula of the distance. This is x1 x2 minus x1 whole square plus y2 minus y1 whole square. So we can say that h minus alpha whole square, okay, plus k minus beta whole square. So this is the distance. But what about the distance of the MP? How can you derive it? So put this point into this equation. So you already know when the any straight line is given and point also given, so you will use this formula, and ax plus by plus c, and you will find the modulus of coefficient of x and y, and put this point into this. The point is h comma k, so you can write ah plus bk plus c upon a square plus b square. Yes, and you already know e square is 1. So now you can put these ps square and e square and pm square in the formula, because you do the squaring on both sides. Okay, so now put this value into this. ps square equal to e square pm square. So what is the value of the ps? ps value is root x minus alpha h minus alpha whole square and k minus beta whole square equal to, because ps we derive the ps and we also derive the pm, and we just talking about the squaring on both sides, so we will do the squaring on both sides. And e square, and you will square on both sides, bx plus ah plus bk plus c upon a square plus b square whole square. So you can write x minus alpha whole square plus k minus beta whole square equal to e square ax plus b ah plus bk plus c upon under root a square plus b square. This is the equation of the parabola, 2-degree equation in xy plane. Okay, so what we have done, first we find the distance of the SP, and SP distance is h minus alpha whole square plus k minus beta whole square, and then we after find the PM and put this point into this equation, which is the equation of the directrix has been given, and AH plus bk by plus c. Equation is ax plus by plus c is given, and put the h comma k instead of this, and find the modulus, and after that you squaring on the both side because the condition has been given, and you will find the final equation. So let's do the question based on these properties. Find the equation of the parabola. Equation of a parabola with focus at 0, 1 and whose directrix is 3x plus 4y plus 1 equal to 0. So in this question, question says that find the equation of the parabola. So parabola is also has been given, so we can say that the eccentricity will be 1. Okay, because we have taught for the parabola eccentricity will be equal to 1. So eccentricity is 1 and focus is, this is the point of the S, and directrix is this. So how can you do this? First you have to find the PS upon PM. Let's take another slide. PS upon PM equal to E, and P is moving point whose coordinate, let's take x comma y or h comma k. You can take h comma k. This is a point moving point P and h comma k, and this is the focus S whose coordinate is 0, 1, and this is the directrix 3x plus 4y plus 1 equal to 0. So now understand what the question says and find the equation of the parabola. So what is the distance of px? You write h minus 0 whole square plus k minus 1 whole square, and e square. What is the distance of the PM? Put the formula 3h plus 4y plus 1 upon 9 plus 16, right? And this will be h square plus k minus 1 whole square. Squaring will be both side. We will do the squaring. it will also E, because till now we didn't any squaring. We will do next is squaring on next line. Squaring on both sides. And what is the value of the E? E's eccentricity is 1 for the parabola, and 3h plus 4y plus 1 whole square by 16 plus 9, 25, and square of the 25 will be 5. So you can do easily. So it will be 5 into h square plus k minus 1 whole square equal to 3h plus 4y plus 1 whole square. Means 5h square plus 5k square plus 5 minus 2 5s are 10k equal to a plus b. Put the formula of a plus b plus c whole square. So tell me, what is the formula of a plus b plus c whole square? So the formula will be a square plus b square plus c square plus 2ab plus 2bc plus 2ca, right? So 9h square plus 4y means 16y square plus 1 plus 2ab means 24hy plus 2bc 8y plus 2ca 6h. So 9h minus 5h will remain 4h square. This is a 16k square. This is a k, okay, not a y, because we are putting the h comma k. This is a k, h comma k. So 16k minus 16 minus 5, 16 minus 5, 11k square, and this is a minus 10k, so it will become plus 10k, and minus 5, and minus 5 plus 1 minus 4 plus 24 hy. Sorry, it's not a y, it's a k. Always remember, it's a k. I make a mistake here. hk plus 8k plus 6h. So this will be the equation of the parabola. Okay, this will be the equation of the parabola. So now you understand how to solve the equations related to the parabola, and we will see the next concept, identifying the conic, in the next lecture. So please like, share and subscribe my channel so that student can see easily this video, and tell me your problem related to the parabola in comment section. I will solve your questions. Okay, so see you in the next lecture. Bye bye.